Welcome to TFL Talking Trucks podcast. As always, I'm Andrei Smirnov from TFLtruck.com. And this episode is very, very special because I have one of the experts that knows everything about truck suspension systems. And it's, of course, Josh from ZF. And on this show, we're going to be talking about, in very much detail, a lot of detail, about GM trucks, specifically GMC Sierra. Also maybe some SUVs from GM, and also maybe just a little taste or hint of what's happening with the new GMC Hummer electric truck. So Josh, thanks for being on the show.
Yeah, you're very welcome. I think maybe the title is a little above and beyond. Hopefully I'm an expert. This very grand gesture there.
So can I call you the suspension wizard?
I mean, as long as it's not in a derogatory sense, I think I'll let you say whatever you'd like.
No, but Jeff, can you please introduce yourself and kind of talk about the company a little bit?
Yeah, so my name is Josh Rodig. I am a calibration engineer with ZF, working on CDC SemiActive dampers, or CDC stands for continuous damping control in this case. I've had the opportunity to work on a lot of products at GM, and excited about tuning dampers and ride quality, and really think that the SemiActive damper has a high potential to do a lot of really cool things to the end customer.
Yeah, so in this episode, I want to learn all about it because I don't think this topic gets enough attention, in fact. And suspensions, especially for off-road trucks, is very, very important, obviously. And so we want to define a few things, like, exactly what CDC is. You also talked about SemiActive, right? I want to kind of discuss that, define what it is. And specifically, let's start with the truck that currently uses this, right? Which is the GMC Sierra 1500 Denali. So can you define, you define what CDC is, continuously damping control, but how does it work?
So CDC, yeah, it's a very cool technology. The basis of it is that we like to be able to control the current that goes to the damper to control the amount of force it generates between a full soft and a full firm character. The way that we vary the current can happen on a very, very fast increment in time. We can talk a little bit about how fast that can happen. We typically say 2 milliseconds, something in this ballpark. But oftentimes what we find is that the faster we switch, we can actually create problems because the damper is switching so fast that maybe the body structure can't handle it. So, but yeah, back to CDC, it's very cool to the customer because we can make a vehicle that weighs 5,000, 7,000 pounds, drive like a Corvette when we're locking the vehicle down in full firm. And then we can also make it ride like a old school Cadillac, where it's very, very comfortable to the occupants. So the end user can really dial in the amount of comfort or the amount of sportiness they want in their vehicle.
That's very cool. So and it's available, like we said, on the Sierra 1500 Denali. Is it also on the Cadillac Escalade? Do you know? Or what Cadillacs?
Yeah, so the Cadillac Escalade is actually it utilizes a competitor's system.
Okay. We won't talk about that.
Only good things to say.
Okay. And then you said a couple of other Cadillacs are actually using the ZF or ZF system.
Yeah, so Cadillac XT4, Cadillac XT5, and Cadillac XT6 all utilize the ZF CDC system.
Okay, but those, of course, slightly different use cases, right? I mean, different vehicles. So let's kind of continue with the truck theme, and then if we want to touch on some other Cadillac vehicles, we can kind of come back to that.
One thing maybe I can branch out on before we do that, maybe it's a good segue to this conversation, is that CDC is really it's adaptable to many different vehicle segments. So we have our product on anything ranging from very, very heavy trucks like the Sierra Denali, or we have it all the way down on the Buick Regal, which is a sedan, weighing in the ballpark of 3,500 pounds, something like this. So the vehicle mass that the wide range of vehicle mass that we can cater to and really develop the vehicle characteristic to is quite wide, and it kind of speaks volumes to the capability of the system.
Yeah, and the other reason why I think I'm very thankful you're here on the show is because recently, in the last months and years, we spent here at TFL Truck, we talked a lot about, some of the other competitor systems, right? For example, the system on the Ford Raptor, which uses quote unquote live, active suspension or semi-active suspension, as we'll define later. There's also now the Bilstein system on the Ram TRX, right? But I don't think we spend enough time about talking about GM. So which is why I think it's really cool that you're here and can kind of shed some light on this. So if you look at the damper itself, I mean, for the truck being the Sierra, how big is it? I mean, what's kind of the dimensions here? I mean, it's diameter I'm talking about.
So I think for the Denali truck, if I remember right, the piston size is 36, and I think the rod size is 22 or 20 millimeters. I think it might be actually different depending on front and rear axle. But yeah, that's kind of a traditional size that we use, and that size can actually be used on anything all the way up from a truck down to a passenger car. So
that's very interesting. Okay, so then in the semi-active system, and let's define it, I guess, and talk about what inputs you're receiving from the vehicle, right? And then how the suspension is reacting, right?
Yeah, sure. So kind of high level from a hardware perspective on the truck, specifically on the Denali truck, there's 3 height sensors. There's 2 on the front axle and there's 1 on the rear axle. In addition to that, the other hardware that we use is an IMU that is internal to the ECU or the control module. So what that does, the control module is doing is it's basically detecting the attitude of the body. And we know the distance from that control module to all 4 top mounts. So if we know that, we can basically detect and understand if the vehicle is rolling, it's pitching, it's heaving. And then once we understand what the body is doing, we can then control the damper to combat the motions that we don't like in the body. In combination with the IMU that's internal to the ECU, the height sensors are also used to help understand what the damper velocity is. The damper velocity is a pretty critical component to understanding the full system's capability, because if we don't know how fast the damper is moving, there's no way we can understand how much current to send to the damper to achieve the force we're looking for. And the last part of this is the rear axle height sensor. Kind of a unique thing specifically to the Denali truck is that it's used directly to understand how much load is in the bed of the truck. And the customer doesn't actually potentially know this unless there's a marketing campaign for it. But the truck will actually detect if there is a threshold load or a load that's in the bed of the truck that's above a threshold. And then it will automatically change into a loaded CDC calibration, which was tuned with additional load in the bed. And what this is doing is it's not actively leveling the truck, but it's mitigating how much body motion the truck has when it's fully loaded or when there's a trailer connected.
That's very interesting. Yeah. So, I mean, that's happening behind the scenes, right?
Yeah, that's correct.
I mean, the driver, may not know this is happening. I mean, they're driving the truck, obviously. But do you also have inputs, if the drivers select sport mode or towing mode, does that affect also?
Yeah, so I think in the Denali truck, there's a normal mode and the sport mode. And also when you go into sport mode, the dampers do firm up and they do provide you more transient roll response as it relates to like steering inputs. I believe it also increases the amount of damping front axle, rear axle to increase or reduce how much pitch is in the vehicle, both on acceleration and in braking driver inputs. So yeah, I think this is also another question that you had from your previous question was, what other inputs are we reacting on? So to kind of touch base on that one, we look at things like vehicle speed. We look at things like brake pressure, steering angle, steering wheel rate, lat accel, and driver demanded torque. So those kind of things are kind of from a high level, the big inputs that are driving factors into what the dampers are going to react on.
Yeah, so I think the theory sounds similar because when I'm looking at some of the other competitor trucks, right, like the Ford Raptor and the Ram TRX, those systems are also kind of receiving some inputs, right? And then the valve and the shocks, like you're saying, I mean, it's kind of reacting and then kind of modifying the way the suspension feels. So what is, what are you guys doing with the CDC system that, very kind of unique and special?
I think the how fast we can react is certainly a part of that. I would say also the bandwidth that the damper can provide. So the delta, what I mean by bandwidth is the delta between the full soft character and the full firm character is very large. And also from a heat and a durability perspective, I think the damper is very good in that character. We have very few warranty returns on the parts. And actually, if you compare a passive damper on a program, or if you have a program that has both a passive damper and a CDC damper, we tend to see that the CDC damper actually is easier on the vehicle chassis. And from a durability perspective, maybe the vehicle lasts longer in that regard.
So just the kind of the shaking or whatever the conditions are.
Yeah, so if you basically, let's take, for instance, if you drive over a pothole or something like that, if you can make the damper absorb that energy and make that energy not go into the top mount and not into the body structure, if you multiply that over the life of the vehicle, the amount of energy that the body is absorbing is substantially reduced. So we've seen some data that would suggest maybe we're better from a durability perspective in the life of the vehicle too. So.
And this system's been around in the Sierra Denali, for a couple of years already in the customer's hands, right?
Yeah, I believe the first one was either 2019 or 2020. Yeah. So
it's been around, and I mean, Denali is one of GMC's Sierra's most popular trim. So that's pretty cool. So let's talk about, everybody says active suspension.
Sure. This is a good topic.
I define it always as it's acting in real time, right? That's the way I would say it, right? It's reacting in real time and adjusting. But there's an extra element, which is why you said semi-active. Can you kind of define that?
Yeah, that's a good question. So in this world of suspension gurus, we have kind of two different ballparks that we play in. Well, maybe three. Maybe the most general would be passive. The middle two of the three would be semi-active, and like the crown jewel would be fully active. Passive means that we just have one force velocity curve, and we ride on that force velocity curve all the time. Semi-active adds two different force velocity curves to the game, and you can vary the amount of force anywhere in between the full soft and the full firm character at whatever the controller is capable of doing. But still, passive and semi-active are still what we'll call a reactionary system, and they will only generate force when the damper is moving.
All right. So the passive shock, I mean, is basically the basic suspension that is on a
your run-of-your-mill car is going to have.
Yeah. So and it's reacting to what's happening on the road, right? And it has one setting, right? It's correct. Built with one job, and that's what it knows how to do, right?
Yeah, and it's compromised because it can't do everything well.
Yeah, because it's kind of like it's compromised, right?
Yeah, so it has to do everything okay, as opposed to doing one thing really, really well, or as opposed to doing everything. Yeah. I think you get the point.
All right. So now the CDC system is not. It's still reacting, but it's semi-active because it can vary its reaction, right?
Yes.
Okay.
Yep. So because we basically have a playground between the full firm and the full soft character, we can vary the current and thus the amount of force that we get to achieve the amount of damping that we're looking for in that given or very specific situation, which is different than the passive damper. The CDC damper should be, you're still going to have compromises, but you're going to have substantially fewer compromises than you would with a passive damper. And a passive damper, you're not going to be able to drive the car like a Corvette on a racetrack and then also drive the car home and feel like you're driving in a luxury vehicle. The CDC can do that to an extent.
Yes, and then fully active is what?
So fully active would mean that the suspension can actually create a force when it's stationary, meaning that it doesn't need the damper to be moving to generate the force. It can fill in, call it like torque fill to your engine guys. From a damper perspective. It can fill that force deficiency that you're requesting, but maybe the damper can't generate it because it's not moving. So what this means to the end customer is that, like, if you see a pothole ahead of you, or if you see a speed bump ahead of you, if you are actively looking at what the road profile is in front of you, you can pick up your tire, or you can push down your tire into the pothole. Picking up the tire would be when you're driving over a speed bump. And the theory is that if you're able to do that and you're able to sync that together with the road profile, that's, in an ideal world, the vehicle should feel like a magic carpet. It should feel like you don't feel anything in the road. So that's where kind of suspension technology is going in the future. And for me personally, it gets me quite excited, because I think it would be pretty awesome to be able to drive down the road and just be totally comfortable. I mean, you think about how this could be partnered with autonomous vehicles when you're not paying attention to the road and you're sitting playing on your phone, or you're trying to play a game in the backseat of your autonomous vehicle. Any little road disturbance is going to be annoying. I know it sounds irrational, right, in today's world, but I think as vehicles evolve and how we use them evolves, we're also going to have to evolve our control algorithms and our strategies on and also what's important in a vehicle too. So
are there some high-end vehicles right now that with the fully active systems on the road right now, or is this a little bit more in the future?
I would say from purely a ZF perspective, we certainly do have a demo vehicle that is equipped with the fully active suspension. If you're an OE and you're looking for some attraction, or you want to see the product, we can certainly arrange to potentially do that. But I would say it's at this stage, it's very much in the development, and there's certainly a lot of kinks that we are working through to try and get it to be ready for the masses.
Yeah, that's very interesting, because I mean, obviously as a driver, you're paying attention to everything that the terrain is doing, right? But like an autonomous vehicle, you may not, or maybe you don't. So
yeah, exactly.
Absolutely, that's very important. So you mentioned, I mean, you work for ZF or ZF, and it's a global company, right? ZF provides not just suspension systems, but steering systems, many other components. So you work in concert with an OE, so like a GM manufacturer. How does that work? You start developing early in the process?
Yeah, so maybe the first part of your question, yeah, certainly we aren't just limited to dampers. From a damper perspective alone, ZF bought the historic company Sachs, and that's where the legacy comes from. But certainly we also offer systems like fully active roll bars, this S-Motion vehicle, which is the fully active system. We also do steering gears, front and rear. Some vehicles are starting to come out with rear steer. That's part of our product. And then also the calibration services that go along with fully integrating these mechatronic devices into vehicles. I guess another talking point would be forward-facing cameras. We also integrate that, and specifically as it relates to dampers and CDC, I think that there's a really nice partnership between those two systems, and being able to detect what the road profile is that's oncoming before it gets to the wheel and tire assembly, and changing the amount of current that the damper has to maybe reduce the load that the chassis absorbs, or to potentially create a much more comfortable riding vehicle over that event. So yeah, from a ZF perspective, the portfolio is quite large, and it's been pretty cool to try to integrate these different systems together into new vehicles.
So when somebody like GM or GMC, they come to you, they say, you have the technology to do this, and so you get into the development cycle basically of that vehicle. Mm-hmm. How many, is it like several years in advance? How does it work?
Yeah, so unfortunately, maybe I don't have the best answer for you on this topic, but certainly I'll give you a stab. So my specific role is once the contracts have been written and the agreements have been made, I just have to go in and execute the calibration or the tuning work. But certainly there's a lot of effort and foresight that goes in, that's involved before I actually get into the vehicle. And certainly those people, their efforts are greatly appreciated, because it makes my efforts much more easy later on down the road. But from a holistic answer here, I would say it could be anywhere from 4 to 5, maybe 6 years of pre-planning before you actually see the product on the road that the customer would be able to go and purchase. So yeah, the amount of time and effort that goes into these advanced mechatronic devices in the vehicles is it's pretty involved. And like you were saying earlier, I think it's quite underappreciated, or maybe misunderstood, of how much integration work is going into this. And certainly that effort is on both sides. It's not just on the ZF side. It's kind of a harmonious effort on both GM and the ZF side.
So are you one of those guys who drives camouflaged vehicles?
I do drive them. It's not what my personal car is looking like, though. But yeah, on occasion, it depends on where the vehicle is in the development cycle. I would be one of the guys driving the camouflage vehicles.
So, I mean, you do a lot of work probably in the virtual environment, right? And also in real world, both?
Yeah, that's a really interesting talking point. Specifically on some more recent programs that we've really developed a relationship with GM, where it's this harmonious attitude with each other, where we're really trying to utilize some of their advanced tools, and we also can integrate well with those. So without giving away all of GM's secrets,
oh, come on.
I would just say that, yeah, certainly there's been a lot of advanced development work on some of the new tools that they have, but maybe we can leave that for a subsequent episode, or you could speak directly to the GM guys about it.
Right, absolutely. So I met some GM guys, a couple of months ago, I guess, maybe 3-4 months ago, when I saw the new GMC Hummer SUV. So, sure. And then of course, at the same time, I also saw the truck that they're working on, and they were telling me from the GMC side, first of all, that program was kind of compressed, right? That, the prototypes that we were walking around and showing on video were about 2 years in the making or so. That's what they were telling me. And a lot of it, of course, was because a lot of it was virtual development. So they were able to kind of accelerate what they were doing. And they also said, oh, and by the way, we're using ZF CDC shocks.
Oh, really? Okay.
Yeah. So
it's interesting that they would say that.
So that's what they said. And then, so right now, the GMC Hummer is not out yet, right? It's not. It's coming later this year, according to them. At the end of 2021, it'll be on sale, according to GMC. So I guess they don't want us to share all the details yet about the Hummer, but they did just mention that it's using the CDC technology.
Yeah, potentially, I won't confirm or deny this point on this day.
Okay.
Until it is officially published, I think I will divert back to my self-imposed rule that if it's not published, we won't talk about it.
Right. No. Well, I published it.
But that doesn't mean that we are not on the GMC Hummer.
Okay. Well, it was in my video, so I guess according to that, it's published. Anyway, but I want to talk to you about specifically the image I have behind me. So if you're watching this on TFL Talk channel, you could kind of see some of the images here. If you're just listening, thank you for listening. But talk about off-road, right? So we talked about, the system is able to react, make, turning maneuvers on road comfortable or also precise, right? There's high precision for the driver. What about off-road? What are some of the challenges there?
Yeah, so off-road does create quite a few unique challenges. So first of all, if you have an off-road vehicle, it does make sense that the dampers would change. And specifically as it relates to CDC, we do have off-road calibrations if the customer so desires it. It's my understanding that the 1500 Denali does not have an off-road mode, but certainly in the XT5 and the XT6, I did do some tuning work off-road. And challenges that it specifically creates is if you're on like a 2-track or you are on some off-road type of area, Typically what you have is asymmetrical ride events that the body has to traverse over. And that directly excites the anti-roll bars, or the anti-roll bars are trying to create a motion that's comfortable. But what it ends up doing is it makes the ride motions very snappy, and you end up getting this thing that we call head toss in the ride community. Mm-hmm. And the drivers or the occupants of the vehicle kind of get thrown around inside of the vehicle. And sometimes if the event's large enough, you'll actually knock your head on the side of the vehicle.
I've done that. I've done it before.
Sounds like you need CDC, I think.
Okay.
But anyway, so what we try to do from the damper side is detect the event in a fast period of time, but then also react on it and drive the damper to full firm to slow down how fast that the roll motion is. And by slowing down how fast the roll motion happens, you can't really reduce the amount of roll, but you will reduce the subjective impression of it, and thus you will hopefully make the vehicle more comfortable.
And you mentioned the anti-roll bar or the sway bar, right?
Yeah.
Can you talk more about it? Is it so? What I'm picturing is, a piece of metal that connects both sides of the vehicle underneath, right? For the
yes, that's correct.
But you're talking about adjusting that too. Can you talk more about that?
So I guess as it relates maybe to the XT6 or relates to that bar is not tunable from the perspective of the end customer, or it's not a mechatronic device. Now we do have an anti-roll bar or a stabilizer bar that is a mechatronic, and that means that we can change it with different inputs. But as it relates to XT6 and Denali, it's not currently that. Okay. The reason I bring up the anti-roll bar is, as it relates to asymmetrical inputs, it's a big enabler to make the vehicle, or it provides a large degradation to the ride comfort. So unlike let's call it like the Jeep Wrangler, which it has a disconnecting bar, and if you're off-roading, traditionally Jeep people will disconnect the bar purely to improve this head toss phenomenon, because they're decoupling the amount of force that's being driven on both the left and the right hand side of the vehicle. So that's kind of the enabler. So on XT6 and XT5, and we can't do that. So what we do in turn is we detect how much roll and how much pitch there is, and we increase the amount of current to try and generate more force to combat that. Similar to what an anti-roll bar would be doing if you had it disconnected, right? We're ultimately trying to make the vehicle more comfortable. So,
and of course, the sway bar is there in the first place, primarily for fast speed cornering. Is that true? I mean, it wants to correct, that motion where you're kind of going around like an on-ramp or something.
Yeah, I mean, like with most things in a vehicle, there's many different use cases for all the different components, and certainly going around an on-ramp is a big one for the anti-roll bar. Also, the stabilizer bar is used in things like we call it fishhook testing. So like trying to flip the vehicle over, the bar is a big enabler for this, to improve this character. But that in combination with CDC, like we're also looking at the steering angle. And if we have large steering inputs or very fast steering inputs, we can stiffen up the dampers differently in compression than in rebound. So let's just take, for instance, we're doing a right-hand corner or a left-hand corner, and the body rolls this direction. So that means this left side is in rebound and the side is in compression. So we can actually have different amounts of force being generated left and right. Likewise, we can also do that same thing on the rear axle. So we can really dial in, I think you were alluding to this previously, we can really dynamically change the transient roll response of the vehicle. So, but what we're not going to be able to do is, like, if you drive on an on-ramp, it's going to reach some steady state roll angle. Now we can overdamp the system to make it take a really long time to get to that roll angle, but we're not going to minimize that roll angle.
Or eliminate it.
Steady state situation. But as it relates to dynamically, in going from here to here, we can slow that down and make it feel like it's rolling less. And then sometimes an ordinary driver would say, oh yeah, this is rolling less, but in reality, it's just rolling slower.
I gotcha. Yeah, I mean, I guess the perfect amount of control is that no matter what the terrain is doing, you'll be level, right? Kind of the skyhook like way of thinking, where imagine if the vehicle is on a piece of string and you're just driving it over the terrain and it always remains level, right? But I see what you're saying, you know, with different driving situations, be it on-road or off-road, you just want to improve the comfort. I mean, that's the ultimate goal, right?
Yep. I think one of the biggest rewards on my side is somebody that knows, they know nothing about how the system works, and they get in the vehicle and they say, oh, it's really comfortable. Well, to me, that makes me so happy, because there's a lot of time and effort that goes into calibrating these things. And I don't want somebody to know that something is going on in the background. The biggest reward is for someone just to say, yeah, it feels like it should be doing what it's doing, but it's just really comfortable. Because there is a way that you can calibrate stuff, and you can make the system be really tied down and really have make it apprehensive to move. But I think in this manner, it doesn't feel natural, and therefore, from my perspective, it's not as comfortable. So kind of what I'm alluding to is there's kind of two different schools of thought as it relates to tuning. There's one where you can have really smooth body control or body motions, and maybe it moves a little bit, but it's always moving slow and it's moving together, and it doesn't feel digital. You can have a different mentality where if it moves, you have so much force that it just stops the movement, but the body is moving and the accelerations are very high. Some people choose to do this. Some always choose to do this. It's not what I like, but I think everybody has different personalities. But yeah, it's a matter of what you want it to be like, and how do you get it there.
Yeah, and I think another kind of effect it has on me as a driver sometimes, for example, driving the Sierra Denali, is it feels like the vehicle kind of shrinks around you a little bit, because it feels good in the standard, but you're driving like a 5,500 pound or 6,000 pound vehicle.
Yeah.
But to the driver, me as a driver, you're like, oh, I mean, this might as well be something smaller. I'm just, just feel natural.
Yeah. So an interesting funny story on the 1500. I wasn't a part of the development team on this program, but one of my colleagues was. They actually, when they did the trailer mode on it, it was so good at mitigating the body motions that people were forgetting that there was a trailer behind the truck. And it was potentially thought of as a safety concern as you're driving on the road, and you're going to drive the vehicle faster than you should be, because you forget the trailer's back there. So to your point, if you're able to make the vehicle feel smaller and more nimble than you can, or than it really is, then that's advantageous. And I think to the end customer, it really results as a sense of comfort. Yeah, there's certainly a lot to talk about with CDC and how it functions, and it's certainly very capable. It's certainly a very capable system, and there's a lot of time that goes into it. So I would say from my side and the ZF team, we appreciate you putting it kind of front and center in the automotive world. So thank you for that. I mean,
from my standpoint, a lot of the times, you're buying a GMC or maybe a Chevy or something else, and a lot of times owners or just general public doesn't know some components may come from the OE themselves, but some may not, right? It's an integration of kind of best of breed, I would say. Sometimes the manufacturer takes components from different areas. Can be a transmission, right? Can be an engine. ZF also does transmissions, by the way.
Yep. I think we left that one out at the beginning. So,
I mean, if you look at the Ram 1500 truck, even 2500 truck, it's they use a lot of, they use 8-speed ZF transmissions, right? So yeah, definitely a lot of different components they try to put together in this best package, right? The best vehicle you can possibly make. We kind of hinted at the Hummer. I guess we won't talk about anything more about the Hummer vehicle. That comes later. We'll get probably more chances to either drive it, within a few months, and also hopefully you can come back and talk to us again about what was done there.
Yeah, I mean, only if I worked on it, I should probably talk about it though.
Okay, but if you didn't, you wouldn't.
I don't think there'd be really a reason for me to talk about it then.
All right, Josh. Well, thanks for joining this episode. I think I learned a lot. I think it's important to know that, because it's a very highly competitive space, right? These, especially truck manufacturers and others, they want to compete for the consumer, attention and dollars, and it's really important to learn, all aspects of it.
Yeah, agreed. I would say certainly every day we're taking lessons that we learn in the development and sending that back to our center of competence engineers back in Germany or in Northville, and always trying to continue to push the bar forward, as we know our competitors are not sitting around being stationary too. So it's a little bit fun in that regard.
Sounds great. All right. Well, we'll probably catch you within a few months, I hope. And as always, guys, these stories you'll find on TFLtruck.com, also TFLOffRoad.com, and of course here on YouTube or anywhere your podcast is found. So thank you very much.